Okay, so when you picture alien life, what pops into your head? I bet it's something kind of Earth-like, right? Blue skies, maybe some oceans, solid ground.
That's the usual image, yeah.
Yeah,
Comfortable, familiar.
exactly. But what if that picture is, well, too grounded? What if life, maybe even whole civilizations, don't need ground at all? What if they just float, drift, soar through these enormous swirling atmospheres?
That is precisely the big question we're diving into today. It's fascinating. Could complex ecosystems or maybe even, technological societies
Mhm.
actually exist in the atmospheres of gas giants? Think Jupiter, Saturn, or even those huge exoplanets we're finding.
Nebula nomads, I like that term.
It captures the idea, doesn't it? These could be life forms, sure, but maybe even future human outposts designed for these cloud worlds. So today, we're going from sci-fi dreams to the actual science. We'll look at whether floating life is viable, how you'd even get energy there, the weird gravity, the chemistry, all of it.
Mm.
And this whole deep dive, it's really built for you listening right now, so you can get the essentials and the, frankly, kind of mind-bending insights from what we've looked at.
Okay, let's unpack this then,
Yeah.
because yeah, it really does challenge almost everything we assume about where lives can, set up shop. You mentioned how different these places are, so maybe we should start there. Before we put life there, what are gas giants fundamentally? Like, what makes Jupiter so different from Earth?
That's the perfect place to start.
Right.
So Jupiter, Saturn, Uranus, Neptune. These are the giants in our own backyard. They're massive.
Mostly.
Hydrogen, helium, yeah, but also other volatile gases.
Hmm.
And the absolute key thing, like you said, no solid surface. Not in any way we'd recognize it.
No ground to stand on at all.
Nope. Imagine falling. Yeah. Just keep falling. Through layers and layers of cloud, denser and denser gas. The pressure and temperature just ramp up incredibly as you go deeper.
Yeah.
And their features, they're just wild. Think cloud layers so dense, with pressures that would instantly crush any probe we send, unless it's heavily armored, storms bigger than Earth, jet streams faster than anything here, and magnetic fields vastly stronger than ours, stretching out for millions of miles.
Wow.
Some even generate their own internal heat, which can be pretty significant, sometimes almost as much energy as they get from the sun in certain layers.
And they often have rings, moons,
Yeah.
like little solar systems themselves.
Exactly. Mini solar systems is a good way to put it.
So not just big, dull gas bags. They're dynamic, complex systems. And connecting this to the bigger cosmic picture, how common are these things out there? Do we see lots of Jupiters around other stars?
Oh, absolutely. That's one of the key takeaways from exoplanet hunting, like with the Kepler mission and now TESS. Gas giants are everywhere. We find hot Jupiters practically skimming their stars, incredibly hot, but still gaseous giants. And we find cold ones way out in the boonies of their systems.
So they're a major part of the planetary census.
A huge part. Which means if we're serious about looking for life or even thinking about where humanity might go way, way down the line, we can't just ignore this super common type of planet. We have to consider them. It forces us to ask if habitable could mean something totally different.
Right. Which brings us back to that core question. Could life actually make a go of it in those clouds? I know Carl Sagan and Edwin Salpeter thought about this way back in, 1976?
They did. A truly seminal paper. They hypothesized about life forms specifically adapted to float in Jupiter's upper atmosphere.
Organisms that just live in the air.
Essentially, yes.
Right.
They didn't need ground. The atmosphere was their environment.
And they had that cool model, didn't they? Like different types of floating creatures.
They did. It was quite elegant. They proposed three main types, like a complete ecosystem. First, sinkers. Tiny little things, maybe microbes or complex organic particles constantly falling from higher altitudes, sort of the plankton of the Jovian sky.
The base of the food chain.
Exactly. Then, the floaters. These were imagined as huge balloon-like beings, like living zeppelins filled with hydrogen or heated air to stay buoyant in the denser atmospheric layers. They'd graze on the sinkers.
Giant living balloons.
Yeah. And finally, hunters. More mobile, predatory creatures, maybe jet-propelled somehow, actively hunting the floaters.
A whole food web just floating there in the wind and gas. Amazing.
It is amazing. And what's exciting is that modern astrobiology is still wrestling with these ideas, refining them, especially now that we know about planets like super Earths and mini Neptunes.
Ah, right. Planets that might be gas-rich, but maybe not quite as extreme as Jupiter.
Potentially. They might have, let's say, more gentle conditions in some atmospheric layers. But even for places like Jupiter, while the challenges are enormous, the pressure, the temperature extremes, lack of solid stuff, those fierce radiation belts.
Yeah, sounds pretty rough.
It is rough.
Yeah.
but maybe not impossible barriers. Think about energy sources. You've got sunlight filtering down. You've got chemical potential energy in the atmospheric gases themselves. You've got massive lightning discharges.
Lightning could be an energy source.
Could be. Providing sparks for complex chemistry. Certain pressure zones might act like natural chemical reactors. It's possible you could get complex aerial ecosystems. And some scientists even kick around the idea that life might start in clouds, never even needing a rocky surface to begin with.
Originating in the air, that completely flips the script on how life begins.
Okay, so if alien life could potentially float, then the next logical, maybe slightly crazy question is, could we? Could humans build floating homes? Could we become nebula nomads ourselves? Well, here's where it gets really interesting. Conceptually, yes. It seems plausible. There's already a solid precedent. NASA, specifically Jeffrey Landis, proposed concepts for aerostats, basically, floating habitats for Venus.
Venus. But isn't the surface like a hellscape?
The surface is absolutely brutal, yes, but way up high, about 50 kilometers up in its atmosphere. The temperature and pressure are surprisingly Earth-like, like a pleasant day, pressure-wise.
Seriously, Earth-like conditions on Venus.
In that specific upper layer, yes.
Yeah.
So the idea was you could have these large, buoyant structures floating there, filled with breathable air, which is actually lighter than the dense CO2 atmosphere, providing lift. That's powerful proof of concept.
Okay, that is a good precedent. So if Venus is possible, what about the gas giants? Where would we try it there?
Similar concepts have been explored for gas giants, too. And Saturn often comes up as, let's say, the most friendly option for floating human habitat.
Friendlier than Jupiter. Why is that?
Primarily because its radiation environment is significantly milder than Jupiter's killer radiation belts. That's a huge factor for human safety.
Right, makes sense. So what would these hypothetical Saturnian sky cities look like?
We're talking speculative engineering, of course. But imagine vast structures, maybe filled with helium or heated hydrogen for buoyancy. Perhaps they could use magnetic tethers or anchors, interacting with Saturn's powerful magnetic field to maintain position or navigate.
Riding the magnetic field lines. Cool.
Yeah. They'd need energy, so maybe huge solar collectors deployed above the main cloud layers. Inside, you could have biodomes, closed ecological systems, using atmospheric carbon and nitrogen to grow food.
Recycling the atmosphere itself.
Exactly. And you'd want descent pods, naturally, for sending robotic probes or maybe even shielded human explorers down into the deeper, more mysterious layers.
But still the challenges. The radiation, even if milder than Jupiter, the turbulence, weird atmospheric chemistry. How do proponents suggest managing those? You mentioned earlier it might be no worse than Mars. That sounds optimistic.
It does sound optimistic, but there's reasoning behind it. For radiation, yes, it's a factor, but the sheer scale of a large habitat provides inherent shielding. Plus, the bulk of Saturn itself shields you from a lot of deep space cosmic rays. It's different from being on the surface of Mars with thin air.
Okay, so the habitat structure and the planet itself offer protection. What about the storms? The turbulence?
Good question. Designs could incorporate active stabilization, like gyroscopes or thrusters constantly adjusting. Or maybe the habitats wouldn't fight the winds but ride them. They could be nomadic, migrating to calmer regions like atmospheric sailboats. Or they could use the gravity well itself, finding stable orbital altitudes within the upper atmosphere, protected from the worst of the external space environment.
So you'd work with the environment, not just against it. That's
Right.
clever.
That's the idea. It's about adaptation, not just brute force resistance.
Okay, taking this even further then. If humans could live there, or maybe some other advanced civilization, what does the really far future look like? What kind of wild possibilities open up?
Now we're really getting into the speculative but fascinating realm. Think about self-replicating machines, maybe huge dirigibles that harvest hydrogen and helium directly from the atmosphere for fusion power. Living factories drifting in the clouds.
Wow.
Or maybe bioengineered organisms, creatures designed to be living ships, perfectly adapted to navigate these skies using biological means.
Like giant organic sky whales.
Something like that. Or take it another step. What about artificial intelligence? Could AI cultures exist purely as software patterns within the planet's magnetic fields? Maybe using the energy in Jupiter's intense radiation belts to power vast virtual worlds?
A consciousness without bodies, just patterns in the magnetosphere.
It's highly speculative, bordering on philosophy perhaps, but it pushes the boundaries of what life or civilization could mean. Could consciousness evolve or exist in purely electromagnetic form, sustained by the planet's energies? Who knows?
That is seriously mind-bending. And if we're talking speculation, what about finding not just life, but remnants, signs of other nebula nomads?
Now, that's a thrilling thought, isn't it? Usually we think about finding alien ruins buried under sand or ice on a rocky planet.
Right, archaeology on Mars or something.
But what if the ruins aren't on the ground? What if they're drifting? Imagine stumbling upon ancient alien beacons still transmitting faintly from within the clouds. Or finding derelict nanofleets, microscopic probes sent long ago. Or even the skeletal remains of vast ancient balloon cities.
Relics floating in the ammonia haze, that paints quite a picture.
It really does. And while it sounds like pure sci-fi, remember, we are taking baby steps in that direction. Missions like Dragonfly, the quadcopter going to Titan, which has a thick atmosphere that's designed for atmospheric exploration. And Juno, currently orbiting Jupiter, mapping its gravity and magnetic fields in incredible detail.
So these current missions are kind of paving the way, laying the groundwork.
In a very real sense, yes. They're giving us the data we need to understand these environments better, which is the first step towards figuring out if life could exist there or if we could ever go there ourselves. It's all part of moving towards this potential nomad future.
It really reframes everything, that whole dream of, living among the stars. Maybe it doesn't start on some distant Earth twin. Maybe it starts closer to home, relatively speaking, in the skies of worlds made of wind and cloud and gas. This whole nebula nomads concept, it's a powerful reminder, isn't it? Life might not need solid ground.
Exactly. It needs energy, it needs the right chemistry, and it needs the ability to adapt. Ground might just be optional in the grand scheme of things.
So what does this all mean? Where does this leave us?
Well, I think it means we need a pretty profound shift in perspective.
Yeah.
It suggests maybe our definition of a planet, or even the habitable zone, needs a serious update. We're so focused on rocky worlds with liquid water, our terrestrial bias is incredibly strong. But maybe we need to look seriously at these vast, turbulent atmospheres as potential biospheres in their own right.
Expanding our definition of habitable.
Fundamentally, it's humbling, really, to think how much we might have limited our own search, our own imagination, just by looking for copies of ourselves in our world. So here's something to chew on, something for you to think about. Beyond just gas giants, what other assumptions are we making? What other biases might be holding us back from seeing where life could truly thrive out there in the cosmos? Where else might we be completely wrong about what life needs?